Solving quadratic and rational inequalities. Let f of x equal x plus 2 times x minus 3. We want to find when f of x is greater than 0 and when f of x is less than or equal to 0. I recommend, whenever you're solving inequalities, to make yourself a sign chart. And the idea is the following. We're essentially going to get a number line, and we're going to find the zeros of f of x. Later on, when we do rational ones, we'll also find where f of x is undefined. That is, the zeros both of the numerator and the denominator. And the idea here is that the function can only change signs when either the numerator or the denominator is 0, at least for the type of functions that we're dealing with. So what we want to do is we want to pick any value of x on each of these subintervals. This one, this middle one here, and the one on the far right. And it doesn't matter which x value you choose. So I'm going to choose anything over in this first interval here. I'll choose x equals negative 4. And then I'm going to plug x equals negative 4 back into my function. You can actually find the value, but it's much easier just to plug it into your factors. So I usually do this in my head, but I will show you what I'm doing. So I'd plug in negative 4 plus 2. And then negative 4 minus 3. Now, I don't really care what it equals. I really only care about the signs. So I get negative for the first factor when I plug in negative 4. I get negative again. So negative times negative gives me positive. And I do the same thing for each interval, because it doesn't matter on this first interval. If I plugged in x equals negative 5, I would have gotten negative times negative. X equals negative 6.7, negative times negative. It doesn't matter. That is, if I choose any x value back here in my first interval, and I get positive for the y value, all x values back here will give a positive y value. So plug in any x value between negative 2 and 3, I get 0. And if I plug into my function, I get positive times negative, or negative. And finally, some x value bigger than 3, I'll just choose 4. When I plug into the function, I get positive times positive, which gives me positive. And now I can easily answer the question. So when is f of x greater than 0? Now, strictly greater than 0. Well, that's everywhere up to negative 2, not including negative 2, because f of negative 2 equals 0, and I'm not counting that. Also, anywhere x is greater than 3. Now, where is my function less than or equal to 0? I can go back and use my chart again, and of course it's right here. So from negative 2 to 3, x is negative, or 0, which means I would also include the endpoints. So we'll do a couple more examples. It's just this idea, but just so we have a little bit more to go with. Let f of x equal 2x squared plus x minus 3. Find when f of x is greater than or equal to 0. So the first thing I really want to do is factor this, certainly if possible. So see if we can factor this up here. I'm going to put this in, and then I'll check myself. I get 2x squared, and I get minus 2x plus 3x Good, it looks like I did that correctly. And then I want to find where this is greater than or equal to 0. So we're going to build our number line. Put our zeros in order from least to greatest. So -3/2 and 1. And we'll do the sign chart. So I'm going to pick any x less than -3/2. Let's say x equals -4. Why not? It's just as good as it was last time. If I plug in, I get negative times negative. Plugging in any x value in between -3/2 and 1, I'll try x equals 0. I get positive times negative. And then similarly down here, anything bigger than 1, I'll try 3. I get positive times positive. And then I can easily answer the question. When is f of x greater than or equal to 0? Well, it's everywhere up to and including x equals -3/2. And then starting at 1 again, so let me put a hard bracket there, 1, all the way up to infinity. Be careful when you're doing these sign charts. Sometimes we get in the habit of, once the first one's positive, we can just switch the signs back and forth. Let me show you an example really quickly where that would not be true. If I had something like this, I'm just going to do this sign chart. I'm not going to solve it, but if I plug in my zeros of f of x here, and then I do some testing, like if I do x equals 0 and plug it in, notice that anything squared is always positive, or 0, at least non-negative. So if I plug in x equals 0, I get positive times negative. If I plug in x equals 2, I get positive times negative. And notice that it doesn't change signs there. Anything bigger than 3, I get positive times positive. So don't get in the habit of finding the first one and then just switching the signs back and forth. Now, how would I do a problem like this if I had a rational function? And I want to solve for when this is less than or equal to 0. Well, I'm going to start the same way. I'm going to factor if possible. And we usually make these problems factorable, but not necessarily. I get x plus 4 times x minus 6. I'll check myself really quickly. Yes, I got that right. And then my denominator was x minus 1. And I'm just going to build a sign chart again, putting all my zeros in order from least to greatest, both in the numerator and the denominator, as such. And then I can test values. Let's do x equals -5. I got to plug it into all three, so I would get negative times negative times negative, which is negative. Picking a value between -4 and 1, let's say x equals 0. I get positive times negative, which is positive. Value between 1 and 6, I'll do x equals 3. I get positive, negative, positive. I'll not do that one because I'm doing it kind of quickly. So if I plug in x equals 3, I get 7 times -3 times 2. And what I really care about is positive, negative, positive, which gives me the negative right there. And then in any x value greater than 6, I'll do 8. I would get positive, positive, positive. And then I have positive. So when is the function less than or equal to 0? Well, it's negative all the way from -infinity to -4. Now, should I include -4? That is, does the function equal 0 when x equals -4? And the answer is yes, because when I plug in x equals -4 into the top, the numerator is 0, the whole thing is 0. So I'll include it like that. And then f of x is negative, less than 0 between 1 and 6. So I'll do 1 and 6. And let's check. Does the function equal 0 and x equals 1? Well, the denominator equals 0, which means the function is undefined. So I won't include 1. How about at x equals 6? When x equals 6, the numerator is 0, which means the function is equal to 0, so I can include 6 as the endpoint.